Hello and welcome to AWS On Air. I'm Steve Roberts, a developer advocate for .NET and PowerShell here at AWS, and today I'm joined by Conwell and Emily. Hey guys, introduce yourselves and please tell our audience a little bit about what you do at AWS.
Hey Steve, thanks for having us here. So I'm Kavaljit Kurmi, working as AI/ML Specialist Solutions Architect at Amazon Web Services, and I work with AWS product engineering and customers to provide guidance and technical assistance, helping them improve the value of hybrid ML solutions when using AWS. I specialize in helping customers with containerized and machine learning applications. Thank you.
Yep. Hey folks, my name's Emily Weber, Machine Learning Solutions Architect. I've been with AWS and the SageMaker team for a good 4.5 years, and so I'm happy to chat with you today.
Awesome. All right, so we're here to talk about options for running different ML workloads on AWS. And I think before we dive into those options, let's step back a little bit, talk about what kind of barriers do these customers typically face today, and how are we helping solve those problems?
Yeah, I could probably take a stab at that. So if you see, right, our customer businesses have found really exciting ways to leverage machine learning for applications such as recommendation engines, object detection, fraud detection, and many more. Now, although the use of machine learning is gaining traction, there are a lot of challenges that customers are facing when they are building this up in their local development environments. And that includes long development times, a high cost, a lack of agility, and a huge complexity that comes with the machine learning environments. Now, these are the key barriers, Steve, if you see, right, that are preventing the use of machine learning from becoming even more widespread. And that's exactly what AWS is trying to solve with this AI/ML stack. Now AI/ML stack, which AWS provides, is pretty broad and deep set of machine learning capabilities that our customers can leverage to build really impactful machine learning solutions. Now, again, when it comes to starting on AWS, there are a lot of different options, and at the end of the day, it all matters on what kind of use cases the customers have, what kind of organizational and cloud strategies they have. But really, if I have to sum it up, the first one is they can use AWS AI managed services that can help our customers quickly add intelligence to their applications without needing any machine learning expertise, which is pretty cool.
So when you say the AI managed services, you're talking about things like Amazon Poly, Transcribe, Textract, those kind of services, yeah?
That's exactly, yeah. So to extract, comprehend. Now these AI services, they come pre-trained with pre-trained complex deep neural networks, which are just ready to be consumed using REST APIs. And as you said, right, there are a lot of different use cases that you can solve using those AI services, like demand forecasting, personalization, fraud detection, and many more.
Okay, cool. So there's a large number of services, large number of capabilities. Where should we start first?
Yeah, and I think AI managed services works great, right? But again, sometimes the customers comes and say, we have a machine learning practitioners who wants to build, train, and deploy their own models. And that's exactly where our Amazon SageMaker service comes into the picture, right? Which is a fully managed service, the most complete end-to-end machine learning platform to build, train, and deploy any kind of machine learning models, right? And it offers complete access, visibility, and control into every stage of machine learning lifecycle. Now, start with SageMaker in case you think you have the required expertise and you want to start building the models from scratch, or leverage any of the off-shelf algorithm that SageMaker provides.
Okay. So I've also heard about things called deep learning AMIs or AMIs. What are those, and why would I choose one of those?
Right. Great question. So if you see, right, now many customers have requirements like portability, hybrid cloud approach, or they kind of have some on-premises standard restrictions. Now, those customers tend to take a do-it-yourself approach where they try to run their machine learning workloads on EC2 machines. And to accelerate those workloads, AWS provides something called deep learning AMIs. Now, these are basically EC2 machine images, which comes pre-configured with a lot of open source deep learning frameworks like TensorFlow, PyTorch, MXNet. And the big advantage of using deep learning AMIs to initialize those EC2 instances is that those frameworks comes tested and optimized to run on AWS instances. So you just select the one which you need. You initialize your virtual machines in the form of EC2 instance, and that's all. You just get started with writing your code.
And even another way to think about it is actually pretty basic. So if you are writing code on your laptop, and you're trying to just get more compute, so say you're running out of
Mhm.
memory, running out of disk, you want to store it somewhere that's maybe a little bit more reliable than your laptop. An easy way to just scale that is to just pop open your AWS console, and then turn on a deep learning AMI. And so, just as Kamal said, a deep learning AMI is this virtual image with TensorFlow, PyTorch, MXNet, all sorts of deep learning frameworks that are optimized to run on AWS, and they work nicely. So they're extremely battle tested. They're updated
Mhm.
with major updates to the frameworks themselves. We run a ton of integration tests to check them against different versions, different configurations, different changes. And so, just as we're saying, the DLAMI is just a great way to open up a box on AWS where you can just get in and start writing TensorFlow and PyTorch.
That sounds really, really convenient. Can we take a quick look at that before we go on?
Yeah.
Yeah. Yep. So let me share my screen.
Okay.
So, yeah. So here we are on the AWS console, right? So
Mm-hmm.
and we are on the Elastic Compute Cloud interface, and I have actually launched one EC2 instance using the deep learning AMI. Now let's quickly see what kind of image that is, right? So if you go to the summary of this instance, you can see what AMI that has been used. Let me open it up in a separate tab.
Mm-hmm.
And you'll actually, Kanwal, while we're on the previous page, you'll notice that's a P3.2XL.
Mhm.
So that means you're running on NVIDIA hardware right now, and you're actually running on a V100, and that's going to have one GPU.
Okay.
Great point, Emily. And if you see, right, Steve, if you want to build up any kind of deep learning environments, right, you need a lot of different libraries. Apart from your deep learning frameworks like CPU libraries, GPU libraries, you need NVIDIA drivers, NVIDIA CUDA deep neural network libraries. And one of the challenge today in setting up those environments is to make sure that all of these libraries work together well, right? And if you use deep learning AMIs, this has already been figured out, right? So you don't really have to mess around with those interdependencies and making sure that all of them really work together. This has been already figured out, and then you just have to select one and can start working on your code.
Okay. So working in the EC2 team myself, I know that we periodically revise all of our images. Does that apply also to the deep learning ones? So we keep them up to date for you?
Yes.
Oh, do we ever? Yeah, you can actually subscribe to our deep learning container repository on GitHub,
Oh,
and get all the latest updates. And so the deep learning containers, we push them out for, we call it E3 actually, so EC2, EKS, and EKS,
Mhm.
and then we also push them out for our higher services, higher managed services like SageMaker.
okay. All right. Is there anything else that you want to show us for this deep learning
Oh
army?
yeah. So this is so if it's like the AMI, just wanted to show you, that you can always go and see that this particular AMI comes with what kind of deep learning frameworks and what kind of
Okay.
library, right? And once you instantiate that, you can actually let me take you to the command prompt. Let me make it bigger.
Oh yeah, let's get quite a few zoom ins on there.
Right.
Yeah,
Yeah.
we'll need to zoom that.
I got a white screen so far.
So yeah, let me SSH into our machine, and once I SSH, I can actually open up a Jupyter notebook.
Can you zoom that text in a little bit?
Right. Let me do that. Is it better?
It's still pretty
It's
small.
still pretty small, but I can see there's a lot of stuff there, so it's working. That's
Yep.
great.
Yeah, I think we just have to see that you just have to SSH to your EC2 instance
Okay.
and just use a Jupyter command to bring up the notebook server. So the best thing here is that these AMIs do come with Jupyter library, so you don't have to install anything on that. And the other thing we do is to just open up an SSH tunnel so that any request to my local port could be forwarded to the remote machine via secure channel. So yeah, I think this is fine. We can go back to our screen and I can open up the Jupyter interface.
Yeah,
Right.
let's definitely zoom in here. I want to see this in all its glory.
Right. Yeah. So one thing is, if you've seen without writing a single code or without downloading any kind of libraries, I'm able to open up my Jupyter notebook and I can start using that to do my machine learning activities. Right.
Now,
Yeah.
Kanwal, are you running this on your laptop, or are you running this on EC2 actually?
So this one is on EC2 instance, but I'm opening up the Jupyter notebook on my local port on my laptop.
Nice.
Yeah. And you see, right, you can actually see the kind of environments that I get on my EC2 instance, which basically is PyTorch, TensorFlow, MXNet, and others. And you can activate any of these environments, and you can start using that to build up your machine learning models. Now, though you can do that, what I normally do is I actually select a particular Jupyter notebook, which I'm using this for this demo is basically the image classification problem on Cypher10 dataset. And you can use the kernel and can switch to any of those conda environments right from here. Okay, so that gives a flexibility to data scientist team to choose any of these frameworks and can start doing the experimentation and model building. Right. So here in this case, we have selected conda PyTorch. Now, before I actually take you through this, let me run all of these cells together, and we can probably just take a minute and probably not going too much into details of this code. So I'm using PyTorch here. We are using PyTorch Vision transformations module to transform the incoming Cypher10 image dataset, basically randomly resized crop, horizontal flip, converting into tensors, and normalization. And finally, we use data loader APIs to really load these images in batches. And finally, we are using the ResNet 18 pre-trained model from the Torch Vision module dataset.
So, Conwell, I have a question for you. So let's say I have my own image, and let's say this is a Docker container that been building out for my own computer vision case. Runs great on-prem, runs great on my laptop, and I just want some extra boxes. What would you say is the easiest way for me to take that image and then run that on a deep learning AMI, for example, or run that on EC2?
Right. Yeah. So if you see, right, all these frameworks are being supported the backend of your Jupyter server. Now, if you have your own custom image and if you still want to, continue working on EC2 instances, you can actually pull that image from your repository wherever it is, and then you can make it work with your Jupyter server, right? And once you configure that on the Jupyter server, the way we chose Conda PyTorch in this case, you can actually select the one which you have downloaded, and then you can start using that to build your models.
Got it. So basically you're saying I could host that in ECR, for example, or even another container registry. And then
Exactly.
basically when I'm sitting in Jupyter or sitting in my, DLAMI launched machine, then I'm going to point to that and then basically download it and try and run it locally.
Right. Yeah. So you can download that. You can give it any custom name, and once you configure that with your Jupyter environment within this EC2, then you will see that in the this particular kernel section. You select the new image from here, and then you can start working on it.
Got it.
Right.
So
Thank
that
you.
that looks super nice for
Mhm.
one person, right? For one developer. But now let's say I'm I don't know, admin for a team of like 15 data scientists, right? And like the last thing that I want is for 15 data scientists to go randomly turn on EC2 instances, right? Like maybe I don't even let them do that. What do I do in that case? What would you recommend?
Yeah, great. I think this is exactly some of the challenges which our customers are facing, right? How do I scale? I'm working on my one EC2 machine. How can I distribute my model across a cluster of various different EC2 machines, right? And there are a couple of things, right? You can definitely combine multiple EC2 machines together, and then you can use all of them for distributed training. However, that in itself is a huge task because you'll have to mess around with networking protocols, ensure that a particular network interface are available, which a data scientist doesn't want to do it by themselves, right? And that's where we highly recommend to containerize your machine learning workloads, right? Containerization is one of the key solutions, which actually helps you encapsulate all of your dependencies and libraries together into one package, and then you can distribute that package across various different machines and could just be sure that these will run consistently no matter where they're running. And that's where our second solution called deep learning containers, which AWS provides, comes really, really handy. Now, deep learning containers do provide with the same deep learning frameworks as we see in deep learning AMIs. However, there comes in a form of container, which you can pull, you can prototype, you can test with that, and even extend that with your own custom libraries, right? So you make it your own, you create those containers, and then use our container orchestration platforms like EKS, which is Elastic Kubernetes Service, or ECS, Elastic Container Service, for really orchestrating your jobs and distribute it across the cluster of your choice, whatever you have configured.
All right, so that's great. So to summarize then, so we have the deep learning AMIs if we want to take the EC2 approach. We have the containers approach if you're using Kubernetes, etc. Earlier on, you mentioned SageMaker. So where does that come into play?
Yeah, totally. No, I'll take that one, Steve. So essentially, again, EC2 is a great start, particularly if you're already familiar with developing machine learning and you're just trying to extend that. But there are many problems at scale. For example, what if I want to go from 1 to 2 GPUs, right? Like in a DLAMI world, then I literally have to turn off my instance, and then I'm going to update the settings, pick P3.8XL, and then restart that. Or what if I want to use a larger data set? I have to go turn on EFS, or maybe I'm going to provision EBS. I have to manually connect those things. And then say I want to track it, right? If I want to run a larger job, but then store some of the metadata, store some of the artifacts, and then make those easily searchable for different team members. All of those questions just started to get more and more complex at scale. And so that's the primary reason why we built Amazon SageMaker, which is a managed machine learning platform across the entire machine learning lifecycle. I can't say this enough. We launched SageMaker Q4 of 2017. And we had 3 awesome things. We had a notebook instance, we had a training job, and we had an endpoint, and we were kicking butt. Basically, like, you could turn on a managed machine to have your Jupyter server, right? And it's fully managed for you, easy to turn on, easy to use, easy to turn off. We had training jobs where you could, launch a remote machine, download your data set from S3 to that remote machine, download your image to that remote machine as well, train your model. We also launched with fully managed real-time endpoints to take your model artifact, turn that into a RESTful API, and then create a endpoint with your model and your image for real-time applications. Since then, we have launched hundreds of other machine learning specific features. We have low code, no code, we have feature store, we have distributed training, we have SageMaker Studio. And on that note, maybe we check it out. What do you think?
I was going to say, can we see SageMaker Studio? Because this, as an ex-IDE developer, this one's like the exciting one to me.
Absolutely. Yeah, give me just 1 second here. Given that I haphazardly pushed a button. All right, how's this looking? Is this coming through?
There it is.
Beautiful.
Yep. Okay.
All right. So first off, you're gonna look at this and you're gonna say, Emily, this is just Jupyter Lab. What's so fancy here? So the big difference is that in a notebook instance, in a DLAMI world, you have one box. You have one machine. You're going to use that one machine for writing all of your code, doing all of your projects, and when you have other projects with different package requirements, you're going to turn on other boxes, right? And maybe you're going to turn off that one. In SageMaker Studio, we actually decouple the UI that is we decouple the server that's hosting your UI from the server that's actually running the compute behind your notebook. So we call those a kernel gateway application. And so in here, you see I actually have 3 machines that I'm running right now. I have a T3 Medium, G4DN, and an M5. So all 3 of those machines are connected to my single Jupyter server that's paid for, by the way, by SageMaker, fully managed and fully paid for, which is lovely. And so that's basically hosting my UI session. But then SageMaker is connecting me out to these 3 different machines. So I can literally go in, I can upgrade each of my notebooks directly to a different compute type. I can change out the kernels, all sorts of goodness. And then the other thing that I can do, in addition to taking advantage of the 100+ features that are available in Studio, FYI.
Studio brings all these together, right?
Yes. Studio brings all of these together in a single pane of glass, really nice user experience. And right now, what I mean, go ahead.
While we were on the terminal, so many of my customers ask us, right? So this looks great, but how does the pricing work? Will the pricing continue to trigger in the background, or I can kind of stop and start whenever I need.
Yeah, so you can turn on and off your instances as you need them. Basically, we have widgets that you can install to sort of automatically turn off all of these machines. But particularly from a training perspective, it's really attractive because again, we're going to launch remote machines with your jobs. So with your data sets, with your scripts. In this case, I'm running a P3.16 XL, so that's going to be 8 NVIDIA A100s. I'm sorry, V100s. And then, yeah, so I have 8 per machine, and I'm actually going to run a GPT-2 sample right here. So this is a very small GPT-2 model. You can take it all the way if you so choose. But so this is running again on SageMaker. I'm using model parallel in the backend to shard my model across multiple GPUs. And then I'm going to pop over to the AWS console. I'm going to check out SageMaker and just give me 2 seconds here.
Mhm.
I'm going to
Yes, we
open
are
up
getting very
training.
close on time. So
Yes, indeed. And so again, just to call this out, in SageMaker, all of the metadata about everything I have just done is fully stored, managed, searchable, and versioned by default. So every job I run, every notebook I touch, every data set that I post in S3, every image I use, all of that is tracked. And so it makes it really easy to scale both with one person and across many, many teams. And so that's why SageMaker is a really interesting choice for machine learning, because you have so many options at scale. And so on that, Steve, back to you.
this is great. So this has been a really interesting discussion. Thanks for joining me today. So we covered deep learning AMIs, we went into the containers, and then we just finished up with SageMaker. But as somebody who's not an ML practitioner, I'm a .NET developer. Not that I can't do machine learning, but it's not been part of my career. If you were just starting out in an ML career right now, what recommendations would you have or advice about the best way to get started, given that we have such a large field of services and tools?
So Steve, I'm going to give you 3 things to do. The first one is to read. Do a lot of reading.
Okay.
There are a ton of blog posts out there, a ton of notebooks, a ton of just pure books, and then hundreds and thousands of research papers. Every algorithm, every method has its own research paper. Eventually, you want to go read some of those. So step 1 is read.
Okay.
Step 2 is just pick a project. Like, don't limit yourself by what's already been built, how other people think about things. Just pick something that you are genuinely interested in, a data set that you just think is cool, that you want to spend some time poking at, and attack it. Try and go crazy on that thing and build an awesome feature engineering solution, build an awesome model, just really, really build a project. And then the third thing to do is to just talk to people. Like, go meet data scientists and go meet, machine learning solution architects and people who are super passionate about it, and just pick their brain and like be super curious about how problems are handled, what questions we ask, why we ask them, how we answer them, and then you'll be in a good place.
Yep.
And then SageMaker looks like an ideal starting position. It brings everything together for me without me needing to dive in.
Yes.
To the bottom with.
Awesome. Just one thing I'll add before we wrap up, Steve. I think AWS as a platform is framework agnostic, right? So no matter where the customers are coming from, what specialization they have, there are services which they could leverage to really continue their work from where they left off, and then enhance it using additional capabilities and feature set, right? No matter if you choose deep learning AMIs, containers, or SageMaker as a managed service.
Okay, this is cool. It's been a great discussion. Thanks so much, Kamal and Emily, for joining me today. And we will be right back. See you shortly.